Hey, so I am sure by now you guys are familiar with the new Pyro workflow in Houdini using the Pyro Bake Volume and the Pyro Advanced Shader. What uh what those let you do is generate a scatter field with the Pyro Bake Volume, mask it with the scattering mask generated in the Pyro Advanced Shader, and that gives you this nice mask scatter emission. Um, there is no default Pyro shader in RenderMan, so I will be showing you the shader that I built that kind of models this pretty closely to the way it's done in the Pyro Advanced Shader. And maybe you can take those concepts and apply it to other render engines like Redshift. So let's take a look. First thing I will be doing is throwing down the configure ground explosion, because that'll give us a really, quick way to build a fireball that we can start kind of testing this shader with. I will be pulling out the trails because I don't want to have to worry about them while I'm building the shader. So I will just remove those like this and pull them out. There are a few things you should change in here. In this export tab, I would enable convert to VDB, and I would resample and use 16-bit float. You need to use VDBs when using RenderMan. It does not have good support for the native Houdini volumes. So after that, we'll go to the Pyro Bake volume and we'll disable the assign material because we will be building our own material. I will also disable the secondary fire because we only want to use this scatter for now. Yeah, other than that, we can put down a cache node. I'll use my cache node and then yeah, cache that out. Okay, so while that is caching, I will go and put down a Pixar material builder, and we'll call this Pyro. And I will assign that to the geometry, which looks like it's already configured. Yeah, so in here, I will also drop down the new Pyro shader, because in here we will be copying out some of the vex that's in there to use in our Pyro shader. Let's see if we have anything cached. Okay, cool. So in here, what we will do is put down a Pixar volume, which I'm sure you have used. We will also import all the fields we will be needing. So those will be density, which is a float. Temperature, which is also a float. Velocity, which is vel, which is a vector. And scatter, which is also a vector. And a quick note on that, the Pyro Bake volume by default is generating a vector color field. So it is a field with this color baked in. If you wanted, you could probably go in here, crack it open, and then export only a float field as a 0 to 1 value instead of a color ramp. And then in your shader, define that color ramp, and that would let you change which colors your fire is after the cache, which could be beneficial. But for now, I'm just going to do it this way because that is how it comes through by default. So now that we have all these fields, we can begin setting this up. So we're going to start with the density. And what you will see in the Pyro Advanced Shader is this use control volume for the density. And what that is doing is it's coming here to this bindings, and it's looking up which control volume to use for the density. By default, it's temperature. When you enable this, it fits the temperature values from this range and uses them as a multiplier on your density. So if your temperature is 0, your density will be multiplied by 1. It'll stay the same. If your temperature is 1, it'll multiply your density by 2. So to recreate this, we're going to be using basically exclusively going to be using the Pixar expression nodes because they let us do all of the operations we're going to want to be doing. So let's take temperature and put it into, actually, we're going to take density, put it into float input 1. We're going to say density equals float input 1. Or say mask equals float input 2. We're going to say mult equals float input 3. And we're going to say temp mult equals float input 4. Cool. So now let's build this mask. Okay. Building the mask is pretty straightforward. We take the temperature. We're going to say temperature equals float input 1. Then we say temperature equals fit. Temperature. Okay, so we're going to fit this from min and max to 0 and 1. We're going to say min equals float input 2. Max equals float input 3. Cool. And what this is doing is remapping our temperature based on the min and max we set here to 0 and 1. And when I'm using these Pixar SE expressions, I will set values that I'm not really going to be manipulating to -1, just so at a glance I know that float input 4 is irrelevant to what's happening inside this expression. So by default in the Pyro Advanced Shader, these values are 0 and 1. So I will just come in here and set this to 0 and 1. Cool. Next, you're going to say temperature equals clamp. We're going to clamp that just so we don't get any negative values and so we don't get any values above what we're expecting. And what you can do now is to export this mask. Well, we'll say mask equals temperature, and we'll just export mask. So the last line without a semicolon, or I guess probably the first line without a semicolon, will be what is exported through these outputs. So in this case, it is just mask, and mask is the temperature that we are manipulating here. So we will take this float value and we will put it into float input 2, where we're reading the mask. But for now, let's visualize our mask. This is going to be temp mask. Cool. So what this is this is essentially just our temperature field, but it's clamped. We're not doing any remapping. We're just taking 0 to 1 and mapping it to 0 to 1. So no real remapping, but we are clamping it. This is our clamped temperature. And you can see that if we start raising this threshold to like 0.5 and 1.5, we get this more crunchy representation. And just a quick note, when you're manipulating these density values in RenderMan, to get it to display properly after changing them, you should restart your IPR, because sometimes when you are changing these density values around, they will not display correctly until you restart. Okay, so we have this mask, but now we want to actually use it to multiply our density. So what we will do is say our mask equals fit mask. So we're going to remap our mask. Currently it's a 0 to 1 value, but we want it to be a 1 to whatever we want to multiply our density by. So we're going to use this temp mult variable that we have set. So now our mask is a, say we set this to 10. Now our mask is a 1 to 10. So that way when our temperature is 0, we're multiplying our density by 1. So it never goes below the density value. But when it's above our temperature threshold, we're multiplying it by 10. 10 is a bit extreme, but just we're going to be using this to visualize. So that'll be handy. Now we'll say density equals mult times mask times density. So our density is going to be multiplied by just a float multiplication, which is just this density scale, times our mask, which is this, times the density float value. And then we can export that by just typing in density without a semicolon. So now we'll set this to 1. So we'll set these both to 1. So we just have our raw density value for now. Okay. So let's visualize this. So if we put our density float, and this is what I'm talking about with the incorrect representation after changing the density. If we restart it, it'll look more like you'd expect. So we have this really non-dense volume. But if we start multiplying the areas where the temperature exceeds our threshold, we start getting these crunchy areas inside of these more kind of diffuse areas here. And you can, keep kind of making this crunchier. Maybe up this a little bit more just so we can see the non-masked areas better. But yeah, here you go. You see this really dense area where the temperature is high and this really non-dense area where the temperature is outside of our threshold range. And the kind of default values in the Houdini Pyro Advanced Shader are going to be 0 to 1. And then this generally defaults to 15, and this is by default 2. And then if we restart the IPR, we should see that represented correctly. So that is probably a good starting point in RenderMan. If you are multiplying your density up, you will slow down the render. The bigger your density multiplication is, the slower your render will go. So just keep that in mind when you're kind of messing around with these numbers. There is one more thing we're going to do to the density. We will be creating the absorption color that you find here. The way we're going to do that is by putting down another Pixar expression. Put this guy into float input 1. And all we're going to do here is say float input 1. Well, let's put the color first. So color input 1 times float input 1. I don't really know if it matters if you're putting the vector or the float first, but I kind of assume that I should put the vector first to set the type, but I have no idea if that's required. So what that does is it makes this first color input 1 our absorption color. So now we can plug in the RGB value into the density color input and disconnect the density float input, and it'll look exactly the same because we have an absorption color of 1. But if you come to the manual, they have this kind of starting point right here, which might be a little extreme because when you plug this in, it's 0.425, 0.36, 0.3, I think. Yeah. When you plug that in, you're going to get some pretty extreme color shifts in your volume. So this blue that you're seeing And that may be differences between the render engine. I could also not be understanding how the absorption color works, but I kind of think this is correct. I was looking inside kind of how they wire this up, and they're doing something pretty similar where they're taking the absorption color, multiplying it by the density. So this is their scaled density. They multiply those two. This is just a switch by default. It is taking the second input and then piping that down to the actual density, which is a vector in the Pyro shader core. So I think that's correct, because that's essentially what we're doing here. We're just taking this color vector and piping it into density color. All right, so now that we have our density field all configured, we can begin working on our scattering / emission field. This velocity will move over here because we don't need it for now. So for scattering, first thing we're going to do is just build a base multiplier for it. So here you can see they have a default 250 multiplier on the intensity. So we will just build that. So we'll take color input 1, plug the RGB values into color input 1, and we'll say color input 1 times float input 1. And we'll set this to 250. And these guys to -1. So now if we plug this into our emit color, you will see the scatter field generated by the Pyro bake volume. And this is, pretty strong because we just multiplied it by 250 and we're not masking it at all. But, if we set this to 100, and I'm actually going to come down and I will reduce the amount of density because multiplying this by 15 is slowing down the render a little bit. So we'll multiply it by 4. And that kind of speeds things up a little bit. But yeah, this is the scattering field. And if you don't know how this is generated, it's essentially the temperature field with plugged into a VDB smooth. So they're smoothing out the temperature field inside of the density area. So I'm thinking they're multiplying it by the density after they do the smooth operation, so it stays inside the border. I could be wrong about that last part, but it is essentially the smooth temperature. So now we'll need to make the mask. So you can see this is the scattering field, and we will need to generate a mask. The easiest way to do that is just copy out the vex code for the mask generation from the Pyro Advanced Shader, because the syntax actually works in this expression field here. So we'll put down this guy, and we'll name this scatter mask. And the input for this it won't be our density, it'll be our final multiplied density before we convert it to a vector. And you can kind of confirm that by looking at here at the bindings and see what is the mask volume for the scattering field. It is the smoke. And why is it the smoke instead of what is the difference between density and smoke? Smoke is the density after all of these multipliers have been done on top of it. So we will be pulling it from here, this float, instead of the raw density. So let's grab the mask vex. So it's just this. It's pretty simple. And something to note, fit expressions in Houdini by default do not clamp the values. Or do they? No. Efit. So fit by default does clamp. Efit does not clamp. So I'm pretty sure about that. Yeah. So by default, fit will clamp, but efit will not clamp. So this is a clamp and a fit function in one. We will have to do a separate fit and clamp function in the Pixar nodes, but just for now, we can just copy this directly. So in here, just paste that code. And we will need to set up inputs for mask. Mask center is what I'll do first because that is the order in the user interface here. It is mask center, then mask width. So mask center, mask width. I think that's what we need. So that equals float input 1. This is going to be float input 2. This is going to be float input 3. And float input 4 we do not need. And by default in the shader, this is 0.2 and this is 0.1. Cool. So now this is all correct, but we will at the end do that clamping as I mentioned. So mask equals clamp mask 0, 1. Cool. Now, we will also need to complement it because if you look in here, they do complement it. So to do that, you just take this clamped value and you subtract it from 1. So there we go. We have generated this mask field. And we can put down another expression. And in here, we need our density, our mask, and our emission. So we will say color input 1 times float input 1 times float input 2. So we're multiplying our emission by our density by our mask. And that is going to become our emission color. And you can see this masked emission that we see in the Pyro Advanced Shader in Mantra. And that's essentially it. We should probably restart this render because we're getting some really strange stuff going on down there, which I hope disappears. It does. Cool. So we can return this value to 250. And yeah, that is the gist of it. You'll want to plug your velocity into velocity here. I see in the manual they pull it from this RGB, the RenderMan manual. They pull it out from here instead of this green position, which is what I kind of would expect, but this seems to work. So yeah, I did go and create a an HDA around this, and it's it's really just what we just built. Maybe I did a couple of these operations I combined a couple of them into one expression node, but it's pretty much identical. The only thing that this has is a divisor on the density. So if you did want, for some reason, if you did want to use this maximum density to drive something, you could go and plug that in here. But I'm not currently using this HDA because unfortunately with RenderMan, if you assign the HDA to your Pyro and then change these values while the IPR is rendering, it will crash Houdini. So I'm just using a setup, and I did save this setup as a a RenderMan preset. So I do have it right here. And that's really easy to do. You just kind of, there's a add button, new material. So you just select your material, click this, and then save it somewhere, and you can access it later. And just some generic notes about volumes in RenderMan. Light source, you should enable this if you need your Pyro to illuminate the scene a lot. Like if you really need this stuff to be illuminating the ground in a way, contributing a lot of light, you'll want to enable this, because if you, like, we can take a look. If I increase this value to like 1,000 and we look at what the emission here, I'll see if I can get a render region going. If we look at the emission down here, you get a lot of these like fireflies out in the distance, and it can take a long time to sample. The idea with that light source, each increment will take longer overall, and you kind of have to stop and restart your render for this to work. But each increment will take longer, but it will be a more uniform distribution of these samples. So in theory, your overall render times will be decreased, even if it appears like it's taking longer to render. And you can see that it's pretty subtle, but you can see that there's less of a kind of speckling out in the distance versus without that setting. But for now, I'm going to turn it off because I'm not really relying heavily on the illumination from the explosion. Multiple scattering is just, it's like in Mantra, if you turn your volume limit up to 1 or 2 and beyond, that is essentially what multiple scattering is doing. It's allowing more bounces inside the volume, and you can see that has a pretty significant impact on the look. Although, in theory, with this pre-computed scattering field, the benefits of enabling this internal scattering are reduced, because you get this fake kind of scattering from this scatter field. So you wouldn't have to turn this on to get scattering from the illumination. You'd only turn this on if you want your lights to scatter properly inside the density, or if you want a more significant effect from the like scattering phase, or this color up here. If you turn on multiple scattering, this will be more extreme. This color up here is separate from the actual diffuse color of the smoke. You'll configure that here. In the Pyro Advanced Shader, it defaults to 0.2. Yeah. So I think that's it. I will post links to the HDA and the RenderMan material preset, as well as some of the Houdini documentation and videos on the new Pyro stuff, so you can go and read those and maybe improve the setup a little bit more. There are some things missing from it, like if you wanted this sort of what they're doing here with this fire tab. I'm not really doing any of this stuff, which it is pretty cool, getting the masked fire field going, or secondary fire if you want to be able to control those trails separately. But for the most part, this will get you very close to the results that you'll see in Mantra. And I'm sure this sort of setup could be replicated in a different render engine pretty easily. Nothing in here is too complicated. It's all just basic multiplication and remapping of values. And this was like the only thing I was copying out from that, directly copying from that Houdini note. But it's still really simple, and you can read the breakdown they show you what they're doing for the mask. It's just this. They're fitting the mask center minus the mask width times 0.5 is the minimum to mask center plus mask width times 0.5. So that's how they do that. And you can see they have a little animation here of the mask center being animated out. And you can see when we move the mask center, we'll have the same sort of animation happening. And if I turn off multiple scattering, we'll get a much faster feedback on that. Or if I maybe create a render region right here, I can get a more interactive look. So yeah, this is animating this value and it will kind of come out of the volume more versus pushing this emission back into the depths of the volume. So yeah, I hope that's helpful. I know I will probably be using this setup on a lot of Pyro. So yeah, hope that helped. See ya.